So now we're at the page that I know people have been struggling with, so we're going to look at 10, 11, 12, which are all proving these trig identities. So the idea with these trig identities is you want to start with one side and work to the other. And here we're going to start with the rational side because it's going to be much easier to make this rational cancel out and give us something that's not rational and going the other way around. So let's start over here with the left hand side of the equation. Alright, and the idea is we want to have just a string of equalities until we get over to the right hand side. So from the start, there's only really one thing we can do. We can't do anything to combine these cosine x's and cosine y's. So the only thing we can do here is in the numerator with cosine x plus y. We have a nice formula for the sum of two angles. So here we're summing x plus y inside of cosine. So we can use our identity that says cosine of x plus y is cosine x cosine y minus sine x sine y. And that whole expression there is still over the denominator here, cosine x, cosine y. Alright. And now we're going to use just a property that works for all numbers, but if you have a plus b over c, we can separate this down into a over c plus b over c. Alright, so a lot of times when we're working with rationals, we go from the right to the left. We get a common denominator and just add the numerators, but since this is an equal sign, we can go left to right as well. We can split this here over the addition and get a over c plus b over c. Alright, so we're going to use this to our advantage here. This piece here, cosine x cosine y, is our a, this sine x sine y is our b, and then cosine x cosine y in the denominator is our c. So we're going to need a, which is cosine x cosine y, over the denominator, which is cosine x cosine y. And then we have to split over the subtraction, and now we have the second part of the numerator, sine x sine y, over the same denominator, cosine x cosine y. Alright, now here on the left side of this minus sign, we have the exact same thing over itself, so that's just going to become a 1. Alright, we still have this minus sign. Alright, but now if we look at here, we have sine x times sine y over cosine x cosine y. We can group those two together like that. We can group, or at least think about it this way, group these two together like that. Alright, well, it's technically this red piece times this blue piece. Well, this red piece is sine x over cosine x, so it's sine over cosine, which gives us tangent of the thing that's in the parentheses. And this blue piece, same idea, we have sine of y over cosine of y, so sine over cosine, again is tangent, but now it's of y, because that's what's in here. So we have 1 minus tan x tan y, which is equal to this, which is what we wanted at the beginning. So we proved this trig identity. Alright, so we don't need a question mark there anymore. We can just have an equal sign. Alright, so this is the idea of all the following proving these identities. We start with one side, just have a string of equalities until we get to the right hand side. Sometimes we'll start with the right hand side and go to the left hand side as well. So I just mentioned for number 10 at the end that sometimes we start with the left and go to the right, and sometimes we go right to left. Well, here we're going to start with the right hand side because we have this rational on the right, and we want to simplify it down to get the more simple thing, which is secant squared on the left. So let's start with cosine x, or cosecant x over cosecant of x minus sine of x. Alright, so we want to try to simplify this down in some way until we just get secant squared of x. Alright, so the first thing, you can look at this, there's no real identities that we have between cosecant and sine, alright, if they're subtracted. Alright, so what I'm going to do to start is just rewrite everything in terms of sine and cosine. So we know cosecant is 1 over sine. Alright, so we're going to get that in the numerator here, 1 over sine of x. Alright, and then the whole denominator, again, this cosecant is just 1 over sine. Alright, we have the minus, and sine we don't need to convert at all because it's already in terms of sine. Alright, so now we have this expression here, which technically looks more complicated, but now we can get a nice idea of what our next step should be. We have these complex fractions, so to get rid of the complex fractions, I'm going to multiply this rational by sine of x over sine of x. Alright, what's going to happen now Well, in the numerator, the sine of x is just going to be multiplied by 1 over sine of x, so it's going to be sine of x over sine of x, which is just 1. And in the denominator, sine of x is going to distribute into both of these terms, so it distributes into the first one. We get the same thing, sine of x times 1 over sine of x, which is just 1. And the second piece, it distributes into sine, so sine times sine is sine squared of x. Alright, so now we took this complicated looking complex fraction and made it 1 over 1 minus sine squared. The next thing we're going to look at is the fundamental identity, which we use a lot in these proven cases. So we have sine squared plus cosine squared equals 1. Well, if we want to get this to look like this denominator here, we need to subtract this sine squared over. So cosine squared is still on this side. But we're going to subtract this sine squared over and get 1 minus sine squared of x. And now if we look back at our equality here, we have 1 over 1 minus sine squared, or we know 1 minus sine squared is exactly equal to cosine squared. So this is 1 over cosine squared. And the last thing, we want to get the secant squared. Well, secant is the same thing as 1 over cosine, so that's one of our reciprocal identities. So 1 over cosine squared is the same thing as secant squared of x. Alright, so I started with this complicated rational. We have this equals that, which equals that. So this secant squared x is always equal to this, which is exactly what we wanted to prove from the start. So number 12 is the last expression that we have to prove. So we have to prove that this left-hand side, 1 plus cosecant squared cosine squared equals cosecant squared. So again, we want to start with the more complicated side here. We have addition, we have more trig functions, so we're going to start on this left-hand side and keep working until we can just get cosecant squared on the right-hand side. So the first thing I'm going to do, we have multiplication between trig functions. And whenever you have multiplication, it's good to rewrite these things in terms of sine and cosine to see if they combine or cancel out in any way. So I'm going to rewrite cosecant. We know cosecant is 1 over sine. So this is 1 over sine squared. Now we still have this times cosine, which is already in terms of sine and cosine. We don't need to change it at all. Alright, so this expression is exactly equal to this. And now when we multiply 1 over sine squared times cosine squared, just rewrite it. The cosine squared goes in the numerator, and the sine squared goes in the denominator. Alright, so now we have 1 plus cosine squared over sine squared. Well, cosine over sine is cotangent, so this expression is the same thing as 1 over cotangent squared of x. And you might not be able to think of a way to simplify this at all, but if you look at the Pythagorean identities, we have that this 1 plus cotangent squared is exactly cosecant squared. Alright, so this expression here, 1 plus cotangent squared from equals cosecant squared, comes from the fundamental identity, and we use it here to just get our final answer. Now we know that this expression that we started with is exactly equal to the last expression. Alright, so now we know this expression at the top is true. So this is a good trick for solving a lot of these proving trig identities. Rewrite things in terms of sine and cosine, what we did in the first step, because very often they'll combine and give you a new trig function. So cosecant squared, cosine squared is the exact same thing as cotangent squared, which you wouldn't see unless you rewrote this in terms of sine and cosine.